Okay. Okay. Uh, Good evening. Today is the first exam day for 2025 technology students. Today, ET first paper, MCQ part. The paper is average paper, ET MCQ paper. Paper average, medium level paper, not too hard or too easy, medium level paper. Okay, now. Okay, for your exam also starting August 10th of August, then 12th of August, your first ET first paper, 12th of August. As I told last week revision, you have only 7 months, right? After this month, no, 8 months. You have only 8 months for ready for the exam. Okay. The ET and BST both papers, sorry, it is ET and BST also. ET and BST both papers, actually BST paper a little bit easy. ET paper average, both average, BST one bit easy this time. The ET and BST both second paper, day after tomorrow. Today 12th, 14th. Tomorrow, day after tomorrow. You have only 1 day. 1 day gap. Okay. Come to the lesson. This is our 13th lesson, right? 13th lesson. In chemistry part, we only discussed thermochemistry. This is our second chemistry lesson, kinetic chemistry. Kinetic chemistry. Kinetic chemistry. Okay. Kinetic chemistry. This kinetic chemistry tute I have included in your tute pack, but the problem you don't have received yet. Then I will give you PDF, right? This kinetic chemistry is very interesting lesson, very interesting and very actually very easy and interesting lesson. Other thing, if you don't have order your tute pack, please fill this Google form within today, because I can final day I have only few tute packs. Yeah, this is your tute pack. You have biomolecule tute, kinetic chemistry tute, and November our refresh papers. All refresh papers I have. This is a tute pack. You have biomolecule lesson, and this is kinetic chemistry tute, and all refresh papers. This is a tute pack. Yesterday I already posted, but you don't have received. Tomorrow, day after tomorrow, you can get the tute pack from your post office. Okay. Okay, I will share. Okay, I'll give you the PDF file. Okay, let me share in the group. Okay, you can download in the group the soft copy. The hard copy you can get in the tute pack. Okay, hard copy you can get in the tute pack. Tomorrow or day after tomorrow you can get the tute pack. Okay, I all order this tute pack. I know, I'm not sure. I only posted 15 tute packs. Only 15. I think more than 15 students. Who not ordered yet? Can you raise hand? Tute pack? This pack? All ordered, right? If not, please order within today. I have only few tute packs for this month. And finally, I can post tomorrow. Every day I can't post tutes. Yeah, if you not filled order in Google form, please fill this within today. Before 12, before tomorrow morning, before tomorrow 6 a.m. Fill this and order. Then I can post tomorrow morning and finish your distribution. Okay, that's all about tutes. Okay, this is our 13th lesson. Up to now, we have covered 12 lessons. This is our 13th lesson. This is kinetic chemistry. You can open your tute soft copy until you receive your tute. Yes, the kinetic chemistry means lesson number 12. Kinetic chemistry. This is your tube. Okay, in kinetic chemistry, this is your full note. Okay, this is your full note. You can see all definitions and everything given here. This is a full note, but in kinetic chemistry, we need to prepare a short note. Written a short note, I am going to give you. Then you can note down in your book and prepare a short note. And full note you can go with your tute pack. You can go printed full tute pack. Then you have both short note and full tute pack. It will be very important for your exam. You do when you have, because now these times for 2025 students, short notes are very important. Therefore, I'm going to give only important point in the kinetic chemistry in the written note, and the full note you can get in the tute. Okay, clear? Okay. Okay, what is the meaning of, now we already discussed thermal heat and thermal chemistry. Heat energy is a physics lesson that discuss physical application of heat energy. In thermochemistry, we discussed how chemical equation involve this heat energy, exothermic, endothermic, different reactions. We discussed how for chemical reactions involve this thermal energy, heat energy. Okay, the heat lesson and thermochemistry, it is same. Mainly we discussed about heat energy, how involved for the physical process and how involved for chemical process in thermochemistry, our last lesson. Okay, now what is the meaning of kinetic chemistry? It is a new area. What's the meaning of kinetic chemistry? The kinetic chemistry mean, understand, it is this kinetic chemistry is a very interesting area. Okay, very interesting if you understood all concept very well, and if you try to practice them and try to practice this concept, you can do final part calculations are very simple. For final part calculation, this basic knowledge very important in the first part. Okay, final part, same as thermochemistry. I think you can remember thermochemistry, we did lot of calculation, more advanced calculation in thermochemistry in the final part. Samely in kinetic chemistry also, at the end of the lesson, we have calculation part, same as thermochemistry, but it is not too advanced than like thermochemistry. It is very interesting calculation, chemical calculations we doing in the final part of the lesson. Okay, let's move into lesson. Okay, now you already know about chemical reactions. In thermochemistry also we discussed chemical reaction. What's the meaning of chemical reaction? Chemical reaction mean reactant, whatever reactant react with other reactant, right? This is a one reactant, it is reactant with other reactant, produce different product by a chemical conversion. That's a simple meaning of a chemical reaction. Reactant, actually simply reactant convert into product by a chemically conversion. It is chemically converting. That's the most important thing. Chemically convert. I told in thermochemistry also, it is not a physical change. The product chemically and physically both different from reactant. Make a clearly we can, as example, think sodium hydroxide is a one reactant. If it is react with HCl is acid. HCl is acid. Now you can understand the product are sodium chloride and water. No, H2 gas. No, water. Sodium chloride and water. Then sodium hydroxide and HCl are the reactants. They are the reactant. They are the reactant. They are the product. Sodium chloride and water is the product, are the product. Then you can understand reactants are totally different, physically and chemically, both different. See, it is a sodium hydroxide is acid, HCl is a powerful base. Sorry, sodium hydroxide is a powerful base, HCl is a powerful acid. Then sodium chloride is a mineral, right? Sodium chloride is a mineral. Water is a liquid. Water you already know. Then they are physically and chemically totally different. Okay, that's the main characteristic. Reactant convert into product. They are physically and chemically totally changed. Totally changed by physically and chemically both. Okay, that is the meaning of chemical reaction. Actually, this kinetic chemistry means the area we're going to study about the rate of chemical reaction. Rate of chemical reaction means the speed of reactions. Reactant convert into product. How about the speed of these reactions? That's the meaning of chemical reactions. Now you already know the chemical reactions. Chemical reaction means reactant convert into product by a chemical conversion. Then the kinetic chemistry means the area of study about the rate of chemical reaction. The rate of chemical reaction. The area we're going to study about the rate of chemical reaction. Rate of chemical reaction. Rate of chemical reaction. The rate of chemical reaction. The main target of this lesson, calculate the rate of chemical reaction. Rate of chemical reaction. How about the speed of the reaction? To measure and calculate the rate of chemical reaction. That's the main purpose of studying this lesson. Okay, I got the kinetic chemistry mean. Then in the lesson I have given the kinetic chemistry is a branch of physical chemistry that studied the rate or speed at which a chemical reaction occur and detailed sequence of steps. Okay, in the lesson we can discuss what is the meaning of this detailed sequence of steps. Okay, that I'll explain in the final part, by which reactant convert into product. When reactant convert into product, that's the meaning of chemical reaction. In this chemical reaction, how about the speed? How about the rate of chemical reactions we studying in this kinetic chemistry? That's the main target of this kinetic chemistry. That's the main target of this kinetic chemistry. Okay, as I told earlier, let's prepare a small short note, right? Okay, write down the topic kinetic chemistry. Kinetic chemistry. Kinetic chemistry. Kinetic chemistry. Okay, write down the first point. The subject area. The subject area. Studying about the rate of chemical reaction. Studying about the rate of chemical reaction. The subject area studying about the rate of chemical reaction is called as the kinetic chemistry. Is called as the kinetic chemistry. Studying about the rate of chemical reaction. Remember, always the rate of chemical reactions is the main target of this kinetic chemistry. In thermochemistry, what is the target? How heat energy involved for the chemical reaction. Okay, if you have this basic the overall understand, then you can very easy to understand this lesson. The thermal chemistry always focus into how heat energy involved for the chemical reactions, right? But in kinetic chemistry, we mainly be going to discuss about the rate of chemical reaction. Rate of chemical reaction. Okay, now if you got any reaction in your grade 10, grade 8, I think you doing chemical reaction in your laboratory from grade 8, I think. Now, starting from grade 8, you doing chemical practicals in your school laboratory, right? Like, then what are the evidence? Think we have chemical reaction. You're doing chemical reactions in your laboratory. You're doing chemical reactions in your laboratory in this type test tube. Okay, then what are the evidence you can identify there is reaction take place in this test tube? What are the evidence? What are the evidence? We can decide there is a reaction take place. There is reaction take place in this test tube. What are the evidence? How you can identify? What are the observations? Fatima, what are the observations? Tell me one. Habib. Okay, send me one by one. Yes, very good. Color variation, color change. Very good. If there are any color change, we can identify there is reaction take place. That's the reason for this color change. As example, you already know the iodine test. Iodine test. If you got glucose, no. If you got what you can get bread sample. How is the bread? If you add iodine already brown in color. Fresh iodine brown in color. When you add into starch surface, starch surface, then what happened? Brown color convert into purple color, right? Brown color convert into purple color. Dark blue to purple color. Okay, these reactions we discussed in the middle of the lesson. Okay, they are the color change, right? Brown color convert into purple color. That's a color change. What else? Color change examples? Yeah, color variation, very good. Color variation, color change. Okay, what are the color changes examples? I'll show you. That's practical in our syllabus. Oh, very nice. Okay, I can't find. There is a biomolecule practical video. I can't. Wait, I'll show you. Give me a second.
Let's learn Benedict's test. Take 5 ml of Benedict's reagent in a test tube, add 8 drops of the sample, boil it for a minute.
Sorry, this is one I couldn't find. Okay, this is that we called as Benedict test. Benedict test that we use for glucose identification or carbohydrate identification in biomolecule lesson. Next week we can discuss. Okay, now you can understand this is a glucose sample. Glucose mean it's a carbohydrate. Carbohydrate.
Note the color change from green to yellow to orange to red
I'll
to
show you
red. It indicates the presence of sugar in the given sample. Let's learn Benedict's test.
This is a Benedict.
5 ml of
Benedict and glucose mix and mixing and heating by a Bunsen burner, using Bunsen burner. Then what happened? The glucose, this is glucose identification test. No, then the result is positive. Then what happened? The first, this blue color convert into green color. See, blue color convert into green color. Then green color convert into gradually yellow color. Yellow. Now it is orange. Orange color. Finally, it is convert into red. That this red color we called as brick red color. Okay, that we can discuss in our biomolecule lesson. This red color we called as brick red color. Okay, however, by color variation, color change, you can identify there is reaction take place in this test tube, right? There is a reaction take place in this test tube that we can decide, conclude by this test. Okay, the color variation is a good observation. Then what else? What else? Other evidence. What else? The second one. Yes, temperature. Yes, temperature variation is very good. If it is exothermic reaction take place, what happens? Surface heating. Surface heating, due to this heating, the surface temperature greater than, in last lesson we already discussed, the surface temperature greater than environment temperature, right? Then heat released to the environment. Do you remember? Temperature variations, very good. Temperature variations. Temperature variations. Temperature variations. Okay, what else? Observations. In grade 8, 9, 10, you did a lot of basic chemical reactions, right? In your science laboratory, chemistry laboratory. Okay, what are the observation when you doing simple chemical test? What are the observation you got? What else? Fatima? What else? Yeah, gas formation, how we can observe? Gas formation can we observe after pain and yes, bubbling. If hydrogen gas formation, hydrogen gas release from this test tube, we can see water bubbles. Water bubble mean bubbles, right? Bubbles, right? Yes, bubbling. Bubbling. Okay, what else? Bubbling mean release gas. Release gas. Okay, what else? Other observations? Yes, sound. Yes, pop sound. Yes, sound also okay. For okay, what else? Simple other observations. Is it possible to have volume change, right? Volume changes. Volume changes. Volume changes. Reactant volume can be changed when converting to product. Reactant concentration fully changing. Reactant volume also can be changed when converting to product. Okay, what else? Very good. Formation of precipitation. Very good, very good. Formation of precipitation. Formation of precipitation. What's the meaning of precipitation, Rehlan? Formation of precipitation mean? Yes, in previous test, previous example I got sodium hydroxide and HCl test. After some time, when they produce product, we can observe some dust or solid particles precipitate, go downwards into the test tube. Okay, that we call as precipitate, 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 precipitate. Okay, what else? I have given a lot of evidence in the tube, right? Tube. See the tube. Okay, the first one, some evidence of desired chemical reaction. A chemical reaction involve breaking and formation of chemical bond. I'll explain that later. Only go to the evidence which is often visible. These observations, those observable changes confirm that chemical reactions take place. Okay, by this observation, we can understand the chemical reaction take place whatever system, right? System we already discussed in last lesson. System mean whatever area we select for the study. Then I told always chemical in chemistry, chemical reactions take place inside a system. That means selected area. Selected area. In previous example, the chemical reaction take place in a test tube. Then the test tube is a system. Test tube is a system. Test tube is a system. Okay. Change in color. This is a color variation. The clear difference in the color of the mixture. Colorless solution turn into brown. Example. Okay. I told brown iodine convert into purple. Like this. Like this. Formation of precipitation. Yes. Formation of precipitate. Solid substance precipitate. Clearly a solid particle. Yes. Evaluation of bubbles. Yes. I explained. If any gas released by any reaction, then we can observe that by bubbles. Bubbles. Change in temperature. Yes. If it is exothermic reaction, we can observe the surface temperature increasing. That's why heat released to the environment. If it is endothermic reaction, surface become cold. Then what happened? From environment, heat absorbed to the system. Okay, that is according to the exothermic or endothermic nature, we can observe temperature changes, right? We can observe temperature changes. And odor with this gas, as I explained, gas release, we can feel some odor, right? Odor or smell or we can change in environment, odor change, smell change. Okay. They are not the main observations. Previous are the main observation, but if you got only few rare, few chemical reactions, we can observe a odor variation also. A new different smell may be developed, showing new substance with distinct properties are formed. Change in state. Yes, physical state can be changed. Physical state can be changed. Physical state of product may be differ from reactants. As example, solid form into liquid and gas release. Okay. change in volume, I explained, change in volume. Change in pH and conductivity. Formation of new substances means new materials with properties different from the reactants. They are not main. Okay, the main factors you need to note down. They are the main factors. I will note down in the board. Main factors you need to remember. They all are observations. Color variation, formation of precipitate, evaluation of bubbles, change in temperature, order change also okay, change in volume. That enough. Okay, in your short note, write down the topic. Some evidence of desired chemical reaction. Some evidence of desired chemical reactions. Some evidence of desired chemical reactions. Okay, write down the first one, color variation. Color variation. Okay, the description given in the tute, I'm not going to give you note, only 4 points. I color variation. The second one, formation of precipitate. Formation of precipitate. Formation of precipitate. Evaluation of bubbles. Evaluation of bubbles. Change in temperature. Change in temperature. Order changes. Order changes. Change in volume. Change in volume. Okay, that enough. They are the main. If you want other factor also, you can remember they are not main factors. They are not main factors. They are the main observation. 1, 2, 3, 4, 5. That enough. Okay, that 5 observation. By this 5 main observation, we can observe there is chemical reaction take place in whatever system. In the whatever system. Okay, that's the main point. That's the main point of this first part. By this evidence, okay, now color variation, bubbling, temperature changes. Now I told in this lesson, what is our main target? What is our main target? To analyze and calculate the rate of whatever chemical reaction, right? Okay, by this evidence, they are the observations. No, evidence observation vitarak. Only by this observation or evidence can we get the rate of chemical reaction. I mean, can we calculate the rate of chemical reaction? Fatima? By this, now think by color variation, the blue color convert into brown color in a particular reaction. Then can we get some value, numerical value, the rate of this, the rate of chemical reaction of this reaction 5, like this? We can't get like numerical value. This type numerical value we can't get. But by this evidence, by these observations, we can get some idea about the chemical rate of chemical reaction. Like if you have 2 test tube, see, if you have 2 equal test tube, both the test tube releasing water bubbles, bubbling, we can observe both test tube bubbling. Then according to the bubbling speed, we can compare, like this type general idea about the rate of reaction we can get by these observations. But we can't get numerical value, exact value for rate of chemical reaction we can't get by these observations. I got the point? Okay, that's the reason we need to discuss this lesson. That's the target of this lesson actually, to get a numerical value for rate of chemical reaction. එක තමා මේ lesson එකේ target එක. I got the point? I got the point, Fatima? Okay, that's the point. By they are the observations, evidence. They are the evidence we can observe in a particular reaction. But by this evidence, observations, we can't get exact value for the rate of chemical reaction. Our target of this lesson is calculate the rate of chemical reaction. But by these observations, we can't get exact value, exact numerical value for rate of chemical reaction. That's why we study this lesson. Our final target, calculate the rate of chemical reaction. Our final target is to calculate the rate of chemical reaction. Okay, up to now, okay. Any doubt up to now? Okay, it is basic actually. Udanya? Okay, I will summarize again what we discussed up to now. The kinetic chemistry mean mainly the area, the subject area, we're going to discuss the rate of chemical reaction. The rate of chemical reaction. Our target, this lesson, our main target, calculate the rate of chemical reaction. First understand this, calculate the rate of chemical reaction. When any reaction take place in a particular system, we can observe, we can identify there is reaction take place in a particular system by this evidence: color variation, temperature variation, bubbling, pop sound, and volume changes, formation of precipitation. Okay, they are the evidence. By this evidence, the problem, we can't get a numerical value for the rate of chemical reaction. We can only get comparison. We can get only some idea about the rate of chemical reaction. Only idea, we can't get a numerical value. Okay, that's why we're going to discuss this lesson next part. Okay, understand. Remember, this theory is concept as a story, then it is very simple. Okay, that's why we're going to discuss the rate of chemical reaction. Listen. Okay, then with star mark, write down this point in your short note. From above evidence can be obtained some idea about the rate of chemical reaction, but can't get a numerical value for the rate of chemical reaction. Okay, that's a main point. Write down it star mark. Quickly note down in your short note. Okay, don't miss any part, any small part of this lesson. It is, if you covered the full lesson, it is very interesting lesson as a story actually. Make a නිකන් story එකක් වගේ. Therefore don't miss any part. Then it is very interesting. Okay, so according to these observations, according to these observations, we can divide, we can classify chemical reactions into main three categories. Okay, I have given a table in our tute. but don't need this table. Let's draw another another classification in our book. Okay, the same thing I'm explaining in a different way for your easy understand. Okay, chemical reactions according to previous observations. Chemical reactions chemical reactions chemical reactions according to the rate of chemical reaction, we can classify it into three main categories. They are, the first one, okay, let's draw this graph with me. Okay, write down the topic. Classification of reactions according to the rate of chemical reaction. This is the topic. Classification of reactions according to the rate of chemical reaction. Classification of reactions according to the rate of chemical reaction. Okay, complete. මාත් එක්කම හදාගෙන යන්න short note එක. Okay, මේ tute එක ඔයාලට you can get this tute tomorrow, day after tomorrow you can get the printed tute. Therefore don't worry. Then today try to prepare complete short note. These short notes, every lessons you need to prepare short notes. Short notes mean now you can understand this tute. It has lot of details, no? But if you now go to thermochemistry, we discuss lot of information. Thermochemistry I short note given, right? And full note I given as a soft copy. Okay, you can compare soft copy and your written note. In soft copy it is lot of details, and you can keep as a resource your note. You can read that, and this short note points you need compulsory to remember. Short note එක තමයි important points. Not only for this lesson, other lessons also I give you a short note and full note both. Then it is very important for your final days of the exam. Final 2 weeks, it is very important, because final 2 weeks you don't have enough time to watch full notes, right? Full notes you don't have time. Therefore you need to prepare every lesson, not only safety, other lessons also. If you need more than 80 marks, you have to prepare and complete every lesson, complete short notes and everything ready for the final days. Okay, now this is a time ready for the final days, because final days you don't have time for prepare short notes. This is the time. Okay, this is the time every lessons we have complete up to now, prepare short notes and separate, put into separate file and label them with name, lesson name, and complete your all lessons at the evident පිළිවෙලට හදා ගන්න. Then it is very simple. Actually this A level not too hard. If you got all exam papers are moderate level, medium, average, always. Not too advanced or too easy. Always exam papers, if you got all past papers, exam paper, think too advanced level and too easy level, exam paper always this level. Therefore any student can get C pass. Any student can get C pass, very easy. Any subject C pass easy. But if you need more than C pass, B means 65 marks, no? B or 75 marks, more than 75, 85, it is bit difficult. That's why it is not too easy. or not too advanced. It is always average level. Um, now you can ask from your 2025 students today paper, same average level. Everyone can get දැන් අපි හිතමු වැඩ කළා නැතිම කෙනෙකුට උනත් 20 MCQ okay. 20 MCQ කරන්න පුළුවන්. But moderately work students, completed student, they can 30 MCQ, they can get 30 marks. But වැඩ කරපුම අයටත් bright students, they can get only 40, 42. But anyone can't get this more than this level. It's not easy. Okay, that's why the exam paper is made for match for all students, all level of students. Anyone can get this C level, but if you need more than C, A or B, you need to do extra effort. Okay, we discussed about short notes. Okay, okay, chemical reactions. According to the rate of chemical reaction, we can classify it into three main categories. The first one is let's starting from very slow reactions. Very slow reactions. Very slow reaction. The second one is the moderate rate reaction. Moderate mean medium. Moderate, that's mean medium rate reaction. Moderate rate reaction. The final one is the high speed reaction. High speed reaction. Okay, we're going to classify it according to the observations. According to the observations. Observations අනුව තමයි classify කරන්න යන්නේ. Okay. According to the observation. හරි. According to the observation. Okay, now what's the meaning of this very slow reaction? Very slow reactions mean it's take more than 1 year actually. 1 year, 2 years, sometimes millions of years for these reactions. See, very slow reactions, very slow reaction. Days, months or years. It is spent days, months or years. Okay, what are the examples I have given in about table? Examples, it's take more than 1 month actually. It take long time, very slow reactions. Okay, tell me examples. Don't send me physical process. I need reactions. Rehlan, I need very slow reaction example. Don't watch the PDF. Dihini, I need very slow reaction example. Yes, polythene decomposition. Yeah, we can consider. Polythene decomposition is a very slow reaction. Okay, what else? Okay, आप मेरे को fill करो. Polythene decomposition. Okay, Fatima, send me example. Quickly. Simple. Examples. Yeah. Kabir. Kabir. Then Dihini. Amina. Yeah, fossil fuel formation. Yes, it's also chemical, the result of chemical reaction. Fossil fuel formation. Yeah, that's one also okay. Others, fossil fuel formation. Others, okay, do you know how to produce soil? Soil හැදෙන්නේ කොහොමද? Amina, how to formation of soil. Fatima, how to formation of soil? Don't know? Rehlan, how to form soil? Soil formation by the rock decomposition. That one also chemical reaction. Rocks due to solidification of lava. It is produced rocks. With time, this is a very slow action. This is a very slow reaction. It takes more than million years for decompose rock. They are the rocks. This rock with time, with reacting, resulting of react with different minerals coming with rainwater, and react with some kind of acid coming with rainwater. They are reacting and decompose. Then rock decomposition and soil formation. Soil formation is a very slow process. Soil formation. Okay, what else? Now, they are very general things, right? In day-to-day life, but you can observe very slow reactions. Tanya? Very slow reaction. Yes, rusting. Rusting means ferrous react with oxygen. That's meaning of rusting or corrosion. Rusting of iron. Rusting of iron. Okay, this type. Okay, they are the very slow reactions. I have given weathering of rocks, that means soil formation, rusting of iron, reaction between oxygen and hydrogen at room temperature. Oxygen and hydrogen, that one also slow reaction. Okay, note down, they are the very slow reactions. Draw this classification and note down example. Very slow reactions. Very slow reaction. Okay, moderate, medium rate reactions. Okay, tell me examples. They are the lot of reactions in our earth, moderate rate equations. Tell me examples. Okay, every reactions you're doing in your laboratory. Sodium react with magnesium, magnesium react with HCl, all moderate rate reactions. They are not high speed or very slow reactions. They are you're doing reactions in a laboratory inside a test tube. They are moderate rate reactions, medium level reaction. Okay, chemical reactions. Commonly, I am writing chemical reaction doing laboratory. What else? In a school laboratory. Okay. School laboratory. Okay, sorry. Okay. Acid-base reaction, metal acid zinc metal mean it is a metal and acid reaction. Decomposition of hydrogen peroxide. Hydrogen peroxide react decomposition also we doing discussing this lesson. Hydrogen peroxide decomposition also normal laboratory reaction, right? Then remember moderate rate reaction mean all laboratory level normal reactions. All normal reactions are moderate level, that's mean medium level. Okay, understood? Fatima, understood? Okay, if you got high speed reactions, what are the examples for high speed reactions? They are highly speed. Highly speed. For moderate rate reaction, if you got fuel burning, note down that no, fuel burning, that one also moderate rate reaction. That means burning reactions, lot of normally burning reactions we called as fuel burning is moderate rate reaction, not high speed reaction. High speed reaction. Okay, what are the difference between high speed reaction and moderate rate reactions? Okay, you can decide the rate by time consumption. For moderate rate reaction, it take minute to hour. That means less than 1 hour. For reaction take place within an hour, 1 hour. But very speed reactions, very fast reactions, less within a second or less than second, the reaction take place and complete. Okay, what are the examples? What are the examples? Rehlan, high speed reaction, very fast reactions. Very fast reactions. One example, inside a petrol engine, fuel or fuel vapor burning. It is, students, petrol or petrol vapor burning inside the engine. Petrol directly burning or petrol vapor burning. Petrol vapor burning, that we called as fuel vapor, fuel gas state burning. It is high speed reaction. Fuel vapor burning. Understand? Fuel vapor burning. Fuel vapor burning. Fuel vapor burning, it is rapid. That's why in petrol engines, it is produced air fuel mixture, right? I think it is, students already know, by carburetor they produce inside the engine produce air fuel mixture. This air fuel mixture provide to the engine cylinder. That is the reason by small spark then spark plug again, by this small spark the it is burning and exploit. That's why the piston push into downward. That's how the engine power is start. Okay, I hope you know. Ewa karada iti wala Amina automobile. Karala din, yes. Then you already know, right? Fuel directly, fuel or fuel vapor burning inside the petrol engine. Amina. Vapor mean air fuel mixture. Air fuel mixture. In diesel engines, what happen? Is it air fuel mixture or direct diesel? Habib. Direct diesel or air fuel mixture burning in diesel engines? Diesel engines, not air fuel mixture. Not air fuel mixture, that we called as very tiny particles of diesel that is produced by injectors. Diesel engines වල තියෙනවා diesel convert into very tiny particles by injectors. By these injectors, very tiny diesel particles provide to the engine cylinder, that we called as injector. I hope it is students already know that. This injectors tama supply karanne diesel. Then it is easy to burn. Okay. Then fuel vapor burning is a high speed reaction. Okay, what else? Other high speed reactions? Nucleic reactions. I think you heard about nucleic bombs. Relan, have you heard nucleic bombs? What are the nucleic bombs then? Where it is attacked by nucleic bombs? Nucleic attack එකක් කොහෙටද? Fatima? It is not the kinetic chemistry I am asking, general knowledge. Yeah, Hiroshima in Japan. Hiroshima and Nagasaki. I think you already know. There was nucleic attack. Nucleic attack mean it is not a physical bomb. Not a physical bomb. It is not a physical bomb. It is a nucleic attack. Nucleic attack mean it is the whole area will be destroyed. That's much. These nucleic reactions are powerful. Nucleic reactions. The bomb mean it is a nucleic reaction. Nucleic level reaction take place in a whatever area. Then due to the speed of this reaction, the entire area, entire animals, humans, all are destroyed due to these nucleic reactions. Nucleic reaction. It is not a physical bomb. Okay. Nucleic reaction. Okay, what else? High speed reaction. And atomic reaction also. Atomic level reactions. Atomic reactions. Atomic reaction. And commonly explosive reactions. Explosive explosive reaction. Explosive reaction. Explosive reaction. Okay, they all are high speed reaction. They are moderate. High speed mean within 1 second or less than 1 second that reaction take place and complete. They are the high speed reaction. No, no, Rehla. It is not high speed reaction. High speed reaction mean just a millisecond complete. It is a normal reaction. Inhale and exhale, normal reaction. High speed reaction mean it is when we think it is complete. That's a fuel vapor burning less than 1 second. Clear? Difference? Moderate reaction and uh, high speed reaction. Light traveling, it is not a chemical reaction. Light then traveling, it's a physical thing. What's a chemical reaction here? We discuss about chemical reaction. Only think chemical reaction. Don't think about the speed. Chemical reactions with high speed within less than 1 second. Okay, Rehlan? Okay. Note down this table classification. I have given in the tube, but not. Okay, finish. Complete? Can I erase? Finish, Fatima? Okay, let's move into the next part. Okay, this is the most important part. Try to get full understand the collision theory of the reaction. Okay, now we're going to discuss in molecular level, the most important part in molecular level, how reactant convert into product. I told when reactant convert into product, what happened? It's totally physically and chemically, it is changed, totally changed, right? The product react comparatively reactant product එක හැදුනම the product is totally different from the reactant physically and chemically both. Physically maybe, but chemically it is totally different. Chemically it is totally different. Reactant not chemically equal to the product, totally different. Okay, now we're going to discuss how this reaction take place in molecular level. What are the molecular level differences take place reactant convert into product? Okay, this is the most important part to understand entire lesson. This is the point you need to understand. If you understood this point, the entire lesson very easy. The full lesson එකම easy if you understood this point. Okay. Okay, think example. This is a reactant. Let's take like this. A is a reactant. A react with B reactant. Then it is produced D C plus D product. You can understand. No, let's take it is AB2 product. AB2 product. Then A and B react. Then it is produced AB2 product. Think A is a solid. B also solid. AB2 is a aqueous. AB2 is a liquid. Physically difference. Physically difference. And chemically difference. Chemically difference, physically difference. Okay. Now, actually how it is changed. Now, think it is a reactant. It is a reactant. This is B reactant molecule. Think both solids, no? The solid structure you already know. The solid structure, they are compacted, then they are tightly packed, right? Solid structure. Imagine the solid structure we discussed last lesson. The solid structure means this is a solid structure. They are highly compact, and intermolecule bonds are highly strong, too strong. Intermolecule bonds, they are highly compact, like this. Compact. Then intermolecule bonds are greater. The B also another solid type. Okay, then what happened when we mix this A and B two reactants? What happened? A and B molecules. Give me a second. Okay, sorry. Okay, what we discussed, A and B, A is a solid object, solid reactant, B also solid reactant. When we mix this, reaction mean reaction to take place, reaction, we need to mix this A and B. Then when mixing, what happened, this A and B reactants collide each other. Collide mean, what's the meaning of collide? Collide. Collide me, Fatima? Collide me? The theory is collision theory. That's a chemical theory. Collide කියන්නේ මොකක්ද? Tanya? Collide me? Hit. Good. Collide වෙනවා කියන්නේ මෙහෙම හැප්පෙනවා. Yes, that's the meaning. Collide mean it is hit to each other. Okay, when we mix in this A and B reactant, what happened? They collide each other. දැන් මේ හැප්පෙන එකට hit වෙන එකට මෙතන ඉඳන් කියන්නේ අපි collide වෙනවා කියලා. ඒක දාගන්න. Collide mean hit together. Hit. Okay, collide. Okay, the word, scientific word is collide, collision. Okay, collisions කියලා කියන්නේ ගැටීම් වල. Okay, collisions. Okay, now A and B reactants, what happen? Collide each other. When collide each other, then what happened to this molecule? They are with these collisions collide each other, hit each other. Then what happened? They are already available bonds. Think this is the A molecule, this is A molecule, this is one of A molecule. The already available bonds with other molecule break down. The B molecule already available bonds with other molecule break down due to these collisions. Okay, it is formed as a new molecule, not new, free molecule. Yeah, due to the collision, already available bond break down and convert into a free molecule. Now think this free A molecule negative charge and B free molecule positive charge. Then what happened? This A molecule, A negative charge molecule, make an attraction to B positive charge molecule. Then what happened? The A and B produce new bonds. A and B hadana alud bonds between different molecules. That's why the products are formed. Understood? I will explain again. When two reactants are mixed in a single vessel, two reactants are mixing in a whatever container, then what happened? This reactant molecule, they are collide each other. When collide, they are already available bond break down and convert into free molecule. This free molecule, negative and positive charge molecules, freely available, and negative charge attract to positive charge molecule. Then negative positive molecule, it is produce new bonds between negative and positive, this free molecule. Then it is produced into new bonds and new compounds. Understood? Very important points. Kabir? I told this lesson is very simple story. Like a story, you need to remember like a story. What happened, how to take place reaction. Now it is a story when I explain like this. But if you try to understand this lesson your own by read books or read the note, it's too advanced. So now after I explained, you can read the note, then it is very simple, but you can't do it alone. You can do, but not easy like this. Okay. Okay. Now what happened in a reaction? Reactant molecule collide each other. Then already available bond with other molecules, it is break down and convert into free molecule. This free negative and positive molecule produce new bonds. Due to this breakdown already available bond and produce new bonds. That's the reason for produce new compound. These new compounds are the product. Understood, Dihini? Tanya? These new compounds are the product. Okay, let's go to the tune. The collision theory. The collision theory requirement, let's see later. Collision requirements a bit possible. Okay, the collision theory is a model that explains how chemical reactions occur and why reaction rates differ. It's opposite that for a reaction to happen, the reaction particle must collide. Reaction particle must collide. Always, this is a theory. You don't need to understand 100%. After I explain, you can understand. However, not all collisions are effective. I will explain what are the effective collisions later. Okay. Okay. After I explain the full part, you can read and understand. Okay. The chemistry parts, the main thing, if you read books and note, you can't understand easy. But the theory behind these lessons very simple. If you know this story and after read the note, you can get full idea. Okay. A and B reactants collide each other, then they are already available bond breakdown. Then this reactant molecule convert into free molecule. Then free molecule, negative and positive charge molecules available in freely, they react each other and produce new bonds. They attract to each other and produce new bonds. They are the product. Clear? Can we explain? Is there any asked question anywhere? Fatima? Can you explain? Still can't? Okay. Okay. Hari, Abbal. Okay. See, now to reactants collide and to produce new products, reactant need three main requirements. Reactant need to fulfill three main requirements. The first requirement is, reactant molecule collide each other. Reactant molecule collide each other. Collide each other. Reactant molecule collide each other. This is the first main requirement that you already know. For bond breakdown, it must collide each other. The second main factor, this trade requirement, all exam papers asking. Okay, hammer paper this question is asking what are the main requirement to fulfill chemical reaction. They are the main requirement. Reactant molecule collide each other. reactant molecule collide each other. The second one is the reactant molecule collide with proper orientation. Proper orientation. What's the meaning of proper orientation? Reactant molecule, not reaction, reactant molecule collide with proper orientation. What's the meaning of this proper orientation? What's the meaning? Simple meaning. Proper mean correct. Orientation mean Dihini. Now don't get it is very complex. It is very simple thing we discussing. I will explain. I will summarize later. It is very simple thing. Now explain. Now answer these questions. What's the meaning of proper orientation? Habib. Proper orientation means proper direction. But you can't use direction. The proper orientation simple meaning hari පැත්තට collide වෙන්න ඕන කියන්නේ. Into correct direction. Correct direction. I will explain one by one. The final one, the reactant molecule collide reactant molecule with sufficient energy. Sufficient energy. With sufficient energy. With sufficient energy. Reactant molecule should have sufficient energy to participate to the reaction. I will explain one by one. Don't worry. Not too complex. Very easy. Okay. Now the first one you can understand. Reactant molecule collide each other. It must for breakdown bonds. These collisions not only collide. It's enough. Collide must in proper orientation. What's the meaning of proper orientation? I have given here. What's the meaning of proper orientation? This is the proper orientation. Proper orientation. Proper orientation means this is a reactant molecule. A is a reactant molecule. A react with B and C. B, C also a reactant molecule. Then A must react with B direction. මේ පැත්තෙන් collide වුණොත් විතරයි product එක හදන්නේ. A plus B and C is the product. I got the point. Then A collide to this direction, then it is not a proper orientation. It is not producing product. It is not producing product. Okay, I got. Reactant must collide with proper orientation. Proper orientation එකෙන් collide වුණොත් විතරයි product හදන්නේ. It is produced product only if they collide with proper orientation. Okay, the first one, okay, collide, reactant molecule collide each other, for bond breakdown need to collide each other. The second point, collide with proper orientation. Proper orientation means correct direction. To break down bonds and produce new bonds, they need to collide in proper orientation. Okay, now okay, right? Hari. Maybe. Hari. The first requirement is reactant molecule collide each other. Collide not enough, they must collide with proper orientation. Proper orientation not enough. If they don't have sufficient energy, they must have sufficient energy for participate to the reaction. They are the main requirement. They are the main requirement. This sufficient energy mean they should have energy level equal or more than activation energy. Activation energy, I will explain. Activation energy is, there's a definition, that's a minimum energy level required for participate to the reaction. Okay, you must understand everything. Okay, any I got very simple idea about them? Any doubt you can ask? Do I need to explain again? Any doubt you can ask it, then it is easy to explain. Fatima, clear? Okay, I will explain again very simply. Pehlan, okay, let's discuss. Okay, okay, I will explain from the starting point. Try to get the full story. It is a simple story. Okay. Okay, now how reactant molecules convert into product molecule. That's the story. Reactant molecule must collide each other, then they are already available bond breakdown. Then due to this positive negative free molecule positive negative charge, they combine together, they attract to each other. Then that's why they convert into product. For this process, that's a basic process that we call as collision theory. Collision theory. That's why due to this collision, these products are forming. Products form when due to these collisions and bond breakdown produce new bonds. That's right, the product form. Okay, that's an okay, right? Okay, they are the main requirement for this process. Main requirement. They are the main requirement for this process. Requirement. Meva tama requirements. Okay, what are the requirements? Reactant molecule collide each other. That's must. Reactant molecule collide each other. The second one, reactant molecule collide with proper orientation. Proper orientation means correct direction. Correct direction. Okay, that's must. The final point very important. The collide this molecule in proper orientation. It is not enough. They should have sufficient energy level. They should have sufficient energy level. What is the sufficient energy? They must have energy level at least up to activation energy. Okay, that's the story of the activation energy. Activation energy mean think AB. Understand this story very well, then you can get the full idea. Okay, then ABC. Okay, ABC are three molecule, reactant molecule. Then think A molecule has a energy level. A ගාව තියෙනවා. The energy level of A molecule 10 joule. The energy level of B molecule 12 joule. The energy level of C molecule 14 joule. Molecule to molecule, the energy level, then person to person, energy level is different. Samely, molecule to molecule, these energy levels are different. Okay, think the activation energy of this reaction. Activation energy, I will explain different definition. The activation energy of this reaction is 12 joule. The activation energy, the minimum energy requirement. Then A molecule react A molecule collide with proper orientation. Two requirements, okay. Colliding, A molecule collide, proper orientation is okay. Now, is it okay to, is it possible to convert into product? Sarmia? Is it possible to convert into product? Fatima? No. Why? It don't have third requirement not fulfilled. It don't have required energy level, right? Very good. It don't have required energy level. It has only 10 joule. But requirement is 12. Requirement is 12. That's the third point meaning. Third requirement meaning. Okay. Now B molecule. B molecule. Yes or no? If it is collide with proper orientation. B, yes or no? B, yes. We have sufficient energy level. They collide in proper orientation, then we can convert into product. See? See? C also, yes. They have enough energy level. They have enough energy. Then they have more than required energy level. The activation energy means required energy. Minimum required energy. Okay. Minimum required energy. Okay. Any doubt up to now? Okay. Very simple. Okay. Just a story. Just a story. Okay. Now, any reactant molecule need to convert into product. If need to convert into product, they must complete this all requirement. Not only collide, it is not enough. They must fulfill these all three requirement. These all three requirement fulfill all three requirement fulfill all three requirements. Requirements. Remember that those all three requirements fulfill collisions we call special name that we called as effective collisions. Effective collisions. Effective collisions mean effective, that means resultful. Effective collisions. Effective collisions. Effective collision means those all three requirements fulfill collisions. That means product producing collisions. Product the collisions able to produce product we call as effective collisions. All requirement fulfill. These all three requirement fulfill collisions we called as effective collision. Okay, that's a full story. Any doubt you can ask. Habib, clear? Okay. Write down the topic. Write down the topic in your short note. Collision theory. Collision theory. Okay, write down the first point with star mark. The collision theory is the collision theory is a model that explain model that explain model that explain how how reactants convert into product, how reactants convert into product, how reactants convert into product, how reactants convert into product in a chemical reaction. In a chemical reaction. Okay, second point. The second point. The second point. It is different. My note different from this one. Don't think about this. The same thing I explain in simple way. The not given things little bit advanced. Now you can advance if you read, but I am giving in simple way. Okay, the second point. Second point. While reactant convert into product, while reactant convert into product, while reactant convert into product, reactant molecules collide each other. Reactant molecule collide each other and they are already available bonds. Collide each other and they are already available bonds. Break down. They are already available bonds. Break down. So they become as a free molecules. They become as a free molecules. They become as a free molecule. So they become as a free molecule. That means this collide molecule break down, then become as a free molecule. Okay, third point. Third point. Due to the attraction of this molecule to other molecules, due to the attraction of this molecule, due to the attraction of these molecules to other molecules, due to the attraction of these molecules to other molecules, they produce new bonds. They produce new bonds between different molecules. They produce new bonds between different molecules. they produce new bond between different molecules. Likewise, produce new compounds. Likewise, produce new compounds called as products. Likewise, produce new compounds called as products. Okay, that's a collision theory. That's a collision theory in simple way. In simple way. Are you clear? Collision theory. Any doubt in collision theory? It is very simple story. Collision theory, bond breakdown. Due to this breakdown, already available bond reactant molecule collision. Due to the collision, already available bond breakdown. Due to bond breakdown, they convert into free molecule. Then negative positive charge, they attract each other and produce new bonds. They are the product. Okay. Okay, next topic. Requirement to complete chemical reaction. Main requirement. The main requirement to complete a chemical reaction. The main requirement to complete a chemical reaction. The main requirement to complete chemical reaction. The main requirement to fulfill the main requirement to complete a chemical reaction. Okay, first one, reactant molecule collide each other. 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 Second one, reactant molecule collide with proper orientation. Reactant molecule collide with proper orientation. Reactant molecule collide with proper orientation. Okay, details given in the tute, you can read. I am only giving very important points, okay? Key points. Reactant molecule collide with proper orientation. Reactant molecule, the first one, reactant molecule collide each other. The second one, reactant molecule collide with proper orientation. Third one, collide reactant molecule with sufficient energy level. Collide reactant molecule with sufficient energy level. With sufficient energy level. With sufficient energy level. Within bracket, equal to O greater than the activation energy. Within bracket, equal to O, sufficient energy level mean equal O greater than activation energy. Equal to O greater than activation energy. Equal to O greater than activation energy. Equal to or greater than activation energy. Activation energy in short we call as AE. EA. That we can discuss in future graphs. Okay, now understand the full story. Okay, up to now, okay, right? Okay, write down below with star mark, red color star mark, those all requirement fulfilled collisions, those all requirement fulfilled collisions are called as effective collisions. Those all requirement fulfilled collisions are called as effective collisions. Those all three requirements fulfill collisions called as effective collisions. only effective collisions can produce products. Only effective collisions can produce products. Okay, that's the theory. That's a story. Okay, then I have given this is the meaning of think. This is a collision with proper orientation, but don't have, if they don't have required activation energy, then it is not producing product. If they react with proper orientation, it is not sufficient. It is not a product. If they collide proper orientation, it's okay, but they can't produce product if they don't have energy level. Okay, they must particles, no reaction has occurs, no reaction, then A and B again, A and B same reactant, no product. See, A and B collide proper orientation. A and B collide proper orientation with energy. Then it is produced C and B product. New product is produced. Okay, then I have given the proper orientation. You can understand if they don't have with proper collide with sufficient energy level in different wrong orientations, they can't produce product. They can't produce product due to collisions with wrong orientation, different orientations. They must collide with proper orientation, correct orientation to produce, convert into product. Okay, they don't need to draw. You can refer the tune. That one you can read. It must the same thing explain. Okay, write down the topic: activation energy. Activation energy. Activation energy. Activation energy. Activation energy. Okay, as I told earlier, the activation energy, always this definitions asking. Okay, if they ask what's the meaning of activation energy, always you need to explain the minimum energy level of the reactant to participate to the reaction. These two words must. Minimum energy level. May highlight kalam tiyen. Reactant. The minimum energy level of, see, the activation energy is the minimum amount of kinetic energy. That's a full definition. The minimum energy of kinetic energy that colliding reactant particles must possess for the collision to be effective and successful produce a chemical reaction. That's a full definition, but in exam, if you have these two words, you can get marks. Okay, write down simple definition. If you can remember, not must remember this definition, you only simple idea you can remember. The minimum energy level of reactants, the minimum energy level of reactants, the minimum energy level of reactant particles for participate the reaction, for participate to a chemical reaction, for participate to a chemical reaction. The minimum energy level of reactant particles to participate to a chemical reaction, for participate to a chemical reaction. Okay, if you read this one, the same meaning given. Okay, if you want, you can remember this definition. No, I written short note definition, both okay in exam. You can get full marks, but you can't miss these keywords. Keyword miss karanna bad. The minimum energy level of reactant molecules to participate, to involve, for participate to the reaction. Okay, clear? Up to now clear? Okay, that's the full story behind chemical reactions. Okay, any doubt up to now? You can ask. Because most the key story of the lesson we discussed, if you understood up to now the story behind the lesson, other all parts are very simple. Okay, send me Udanya, Tanya, Dihini. Clear up to now? Amina? Fatima? If you don't have full idea, please ask Rehlan, because this the full idea about story very important for our future discussions, because to understand the rate of chemical reaction and the this is actually the mechanism of a reaction, right? That's how the reaction take place, actually how reactant convert into product. Due to this reason, reactant molecule collide each other, then convert into uh, collide each other and break down their bonds and produce new bonds between reactant molecules. Okay, that's the story. For this process, main three requirement must fulfill. They are the colliding, collide with proper orientation, collide with sufficient energy level. This sufficient energy level is the activation energy. The activation energy definition is the minimum energy level of reactants to to participate to a chemical reaction. Okay, that's the story. Kabir, Rehlan, clear, right? Okay, you need practice. Okay, now you can remember everything. Okay, but you need to revise one more time uh, tomorrow. Tomorrow, after class, you can remember, but tomorrow you need to revise one more time. Then you can get long term memory. Long term, you can keep in your mind the story. Again, you need to revise a lot. තනියෙන් මතක් කර. Okay, now actually the lesson starting. I told what is the target of this lesson, to calculate the rate of chemical reaction. Calculate the rate of chemical reaction. Okay, then this is the rate of chemical reaction. The rate means speed of a chemical reaction. How about the speed of chemical reaction? How about the speed of a chemical reaction? Okay, reactant. Any chemical reaction, you already know reactants convert into product, that you already know. Okay, always understand reactant convert into product, reactant convert into product, while reactant convert into product. Okay, how about the initial concentration of product? Initially no any product produced, right? Initial point, Therefore, product concentration initially 0. That you must understand. The product concentration of initial point, it is 0. Reactant in initially maximum concentration. Initially the reactant concentration maximum, right? The reactant concentration of the initial point, it is maximum. Then what happened when the reaction take place? Reactant concentration, what happened? Reactant concentration gradually decreasing and product concentration increasing. Can you imagine? Product concentration increasing. Reactant concentration or reactant number of molecules gradually decreasing and product concentration increasing. Product number of molecules increasing. Okay, that's a normal story, normal scenario. Reactant concentration gradually decreasing and product concentration gradually increasing. Product concentration gradually increasing. Reactant concentration decreasing and product concentration increasing. Okay. Now, what is the meaning of this rate of chemical reaction? Then what is the rate of chemical reaction? Rate of chemical reaction. Then what is a rate? Rate of chemical reaction. What is a rate? Remember, rate of chemical reaction mean reactant. Oh, as example, reactant, think initially concentration 10, gradually decreasing, right? 2, up to 2, decreasing. Initially product concentration 0, gradually it is increasing up to 8 or 10, right? Increasing, concentration decreasing. Then the rate of chemical reaction mean, the rate of chemical reaction we called as capital R. The rate of chemical reaction means the concentration change of any reactant or product within unit time. This is the simple meaning of rate of chemical reaction. Concentration change reactant or product within unit time. That is the rate. Rate means speed. No? Speed always we measure according within unit time. This is the concentration change within unit time that we call as rate of chemical reaction. The rate of chemical reaction. The rate of chemical reaction. The rate of chemical reaction can be defined as the reactant or product concentration change over unit time. Reactant or product concentration change over unit time. This is the equation. Rate mean capital R, concentration change divide unit time. The symbols we can discuss the end of the lesson. The delta mean change. I think you can understand. Okay, write down the rate of chemical reaction is the topic. Okay, quickly note down because today we need to discuss up to these factors. These factors. Next week, then we can start about factors and complete about factors. Then last week we can complete the lesson. Very simple lesson, actually. Okay, write down the rate of chemical reaction. Write down any chemical reaction. First point, any chemical reaction, the reactant concentration gradually decreasing. The reactant concentration gradually decreasing, within bracket decaying. Decaying here. Decaying mean, what's the meaning of decay? Okay, stop writing. And what's the meaning of decay? The reactant, any chemical reaction, the uh, reactant concentration decreasing, within bracket decay. What's the meaning of decay, Fatima? What's the meaning of decay? Anyone? The meaning of decay? Yes, same as decomposition. Decompose. Oh, in Sinhala අපි කියන්නේ ඒකට වැය වෙනවා කියලා. Has decay. වැය වීම. Decay. Within bracket decay. And close the bracket and products. Product concentration gradually increasing. Product concentration gradually increasing. Within bracket producing. 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 Okay, now you can understand. Always reactant concentration decay. Product concentration producing, right? Producing. Product producing and product producing and reactant decay. Okay. Quickly draw this. Quickly go draw this. Only this box. Okay. Finish. Finish. Okay. Then write down with red color star mark. Red color star mark. The rate of chemical reaction is the rate of chemical reaction is the concentration change of reactant or product, the concentration change of reactant or product within a unit time, within an unit time. The concentration change of reactant or product within a unit time, within a unit time. Okay, now write down the rate of chemical reaction equal concentration change divided by time. Concentration change divided by time. Okay, that's enough up to now. The rate of chemical reaction mean capital R. It is concentration change divided by uh, time. Okay, always reactant decaying rate it is negative. Producing rate it is positive. Uh, that we can discuss in the calculation part. Okay, that we can discuss in the calculation part. It is negative. The reactant concentration change negative. If you want, I will explain. See, reactant concentration change. If you got reactant concentration change, what's the meaning of concentration change? Final concentration minus initial concentration, right? Then final concentration, if you got reactant, final concentration minus initial concentration, 2 minus 10. It is minus 8. Minus 8 minus 2 minus 2 minus 10, then it is minus 8. Minus 8 over whatever type. Then always reactant decaying rate minus. Reactant decaying rate minus always. That we can discuss in the final part. Okay, product producing rate minus or positive. It is positive because final concentration 8, initial concentration 0. 8 minus 0, it is positive. Okay, now generally know it. It is negative and the product increasing in the concentration, therefore it is always positive value. Therefore, it is always positive value. Okay, that we can discuss later. That's not important now. Okay, then I have given the standard unit for the rate of chemical reaction, MOL dm minus 3 s minus 1. That one also we can discuss later in our calculation part. Okay, come to our final part of today. Final part of today. Factors affected to the chemical reaction. Okay, write down the topic, the factors affected to the chemical reaction. Factors affected to the chemical reaction. Factors affected to the chemical reaction. Factors affected to the factors affected to the rate of chemical reaction. Yeah. Factors affected to the rate of chemical reaction. We're going to discuss about rate of chemical reaction. Factors affected to the rate of chemical reaction. Okay. These factors affected to the rate of chemical reaction, we can classify it into two main categories. Factors affected to the rate of chemical reaction, we can classify it into two main categories. The first one is main factors. Quite is triangle. The first one is main factors. The second one is extra factors. No? Yes, extra factors. Extra factors. Extra factors. Factors we can classify it into two main categories. extra factors and main factors. Okay, remember main factors, very important. The main factor is temperature. The first main factor, temperature. Temperature. The second main factor is reactant concentration. Reactant concentration. Reactant concentration. The third main factor is catalyst. 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 Note down, okay. Catalyst. The final main factor, only 4 factors, main factors. The final main factor, physical state, reactant physical state, reactant physical state, reactant physical states, reactant physical states, reactant physical states. Okay, they are the main factors affect on rate of chemical reaction. Okay, they are the main factors affect on rate of chemical reaction, note down. Main factors. Okay, what are the extra factors? Extra factors, first one, light. Second one, pressure. Third one, pH value. Fourth one, UV radiation. Okay, they are the not only 4, more than that, but that enough. Pressure, light, pH value, UV radiation. They are extra factors. Okay, in this lesson, we only going to discuss about these main factors. We're not going to discuss about extra factors. Okay, that's the final story. Need to remember. In this lesson, in kinetic chemistry lesson, our next week, our next second part of the lesson, complete the factors affect on how temperature affect. It is a long story. Okay, how reactant concentration affect to the rate of chemical reaction, how catalyst affect to the rate of chemical reaction, how reactant physical state affect to the rate of chemical reaction. In our syllabus, these factors also affecting. Okay, remember, light also affecting, pressure also affecting, pH value affecting, UV radiation affecting. But in this lesson we're not going to discuss these factors. That's a difference. That's why we divide. Actually, light, pressure, they are also affecting. Clear? These factors also affecting, but in our lesson, our syllabus, we're not going to discuss these factors. We only going to discuss these main factors. Okay, clear and complete? Rehlan, complete? Can I raise? Fatima? Okay. Okay, write down star mark. Write down the star mark here, at the star mark. In our syllabus, we only discuss further about main factors. Main factors affect on rate of chemical reaction. In our syllabus, we only discussed main factors affect on rate of chemical reaction. We're not going to discuss extra additional factors, but those factors also affect on rate of chemical reaction. Clear? But they are not much affected. They are in slight levels, small levels. They also affecting, but we not consider in our syllabus. But practically, they also affect. Okay, that's the today lesson. If you any doubt, please ask, because this today lesson very important for the entire to understand entire lesson. If any student came for next week class, they can't understand anything in kinetic chemistry, because today is the basic things we discussed, the key points we discussed in the lesson. Okay, I got any doubt? And you have before next week you will have your tute pack. Get your tute pack and complete these points. And for this tute pack you don't need to any payment. You only need, I think, 250 postal fee only you need to pay. Therefore please order this, otherwise we can't continue our other parts of this month. Okay, any doubt? Everything clear? Okay, then let's meet next week with this main factor one by one discussion. Okay, good night, goodbye.